Okay, folks, back again for video 22, chapter 5.1. So linear inequalities in two variables, and we'll talk about inequalities and how they split up the xy plane. And so we'll do a single equation, actually not an equation, an inequality, and that'll be like problems 1 through 4, 7, 8, and 11 through 14 in section 5.1. And then a single equation with non-negative restrictions, which is like problems 33 through 38, 41, and 42 in 5.1. Given a graph, how can you figure out what the inequality is that gives rise to it? Problems 21, 22, 25, and 26 in 5.1, and then some word problems 15, 17, 19, 27, 29, 31, 43, 46, and 53 and 54. Okay, so graphing linear inequalities. What's this? So, example 1, graph the linear inequality 6x minus 3y is greater than or equal to 24. Also, graph the set of points that do not solve this inequality. So we want to know what points in the plane with x-coordinate x and y-coordinate y satisfy this inequality. The x-coordinate times 6 minus the y-coordinate times 3 is greater than or equal to 24. So how do we go about doing this? Step 1, graph the line 6x minus 3y equals 24. So replace the inequality with an equal sign and graph that line. What's the fastest way to do this? Well, if you remember back in, gosh, it must be chapter 1, back in January, the easiest thing to do is find the x-intercepts, right? X-intercept, you set y equal to 0 and solve for x, so that's 24 over 6, which is 4. And find the y-intercept, which is 24 divided by minus 3, which is minus 8, right? So to find the y-intercept, you set x equal to 0, so ignore this term and just solve what's left for y. Great, and so once we have the x-intercept and the y-intercept, it's fairly easy to graph, right? Minus 8 is down here somewhere. Graph goes up and hits the x-axis at 4, and so there's our line. 6x minus 3y equals 24. Now, what do we know about this line? What does it mean to be a point on the line? Any point on this line, if you plug its x-coordinate and its y-coordinate into this equation, you'll get 24, right? So if x is 0 and y is minus 8, 6 times 0 minus 3 times minus 8 equals 24. And if x is 4 and y equals 0, so if we're sitting at that point, then 6 times 4 is 24, minus 3 times 0 is 0, so 24. So this point, if you plug in x equals 4, y equals 0, you get 24. Now suppose we go off the line a little bit. What happens if we go off the line a little bit to the right? Suppose we look at the point x equals 5, y equals 0. What do we get then? Well, 6 times 5 minus 3 times 0 is actually 30, which is strictly bigger than 24. And that makes sense, right? Because if you make x a little bit bigger, right, by 1 unit, you're going to pick up 6 more units here, because it'll be 6 times 5 instead of 6 times 4. And so you got to actually end up bigger than 24. And if you keep going to the right, x equals 6 or x equals 7, this term is just going to get bigger and bigger and bigger. And it doesn't really matter where you start. Even if you started here, where x equals 0 and y equals minus 8, if you go over to x equals 1 and y equals minus 8, then you'll be adding 6 times 1 minus, well, plus 24. That's minus 3 times minus 8, and that'll be 30 again. So if you leave this line and head to the right, the points out here, when you plug them into this equation, you get things bigger than 24. So this side has 6x plus, minus 3y bigger than 24. What about this side? If you leave this point and you go to the left, you start somewhere on the line and you go to the left. Well, if we leave this point and go over to 3, so x equals 3, y equals 0, this point, what do we get if we plug that in here? Well, we made x a little bit smaller, so we get 6 times 3 minus 3 times 0, and that equals 18, and now that's less than 24. So if we go to the left this way, then you'll be decreasing this term and not changing that term at all. So we end up with, on this side, 6x minus 3y is less than 24. And so this is true for any line in general, right? If you have a line with an equation in there, an equal sign, that gives you a line. One side is greater than and one side is less than. And what we're interested in is which side is which. So in this case, we're interested in 6x minus 3y greater than or equal to 24. So let me draw a slightly tidier graph. Right, we've got an intercept of 4, a line, an intercept of minus 8. Notice that when we do these graphs, you don't need to be super accurate or anything. Usually it's easier just to draw the line and then put in the numbers afterwards. It's greater than or equal, so we want a solid line here. And greater than side is this side on the right here. So maybe I should shade that in red or something. But this inequality, the solution to it is all the points in the xy plane on this side of the line and the line itself. So if I pick any point in here and I take its x-coordinate, its y-coordinate, and I plug it in here, I'll get some number that's bigger than or equal to 24. Now the second part of this problem was, what's the set of points that do not solve this equation? Inequality. So let's take this and come down here. This is the solution of it. The complement or the negation of this inequality is we're looking for points that satisfy this equation. 6x minus 3y is less than 24. Right? And what's that going to be? Well, it's going to be the same line. Right? And x equals 4, y equals minus 8. But it's a strictly less than, not a greater than or equal. So what does that mean? Instead of having a solid line like that, what we want is a dotted line to indicate that we do not include the line. And then this is the side of the line that's less than 24. So the solution to this equation, this inequality, is this side of the line, but not the line itself. So any point over here, if we pick a point, say like 0, 0, and it continues down here. If we pick a point like 0, 0 and you plug that in, what do you get? 6 times 0 minus 3 times 0, that's 0. That's less than 24. Any point over here will have less than 24. So graphing a line, what does that mean? Well, graphing an inequality, a line splits the plane into 3 regions. The line itself, places where it's greater than, places where it's less than. And that's what we want to figure out where those regions are. Okay, so here's another problem. Graph the linear inequality 30x plus 20y less than 600 with these non-negative restrictions. So we'll start again by graphing the line, in this case 30x plus 20y equals 600. How do you do that? Find the x-intercept, and that's 600 divided by 30. And that is 20. And the y-intercept, which is 600 divided by 20, and that's actually 30. Right? So 600 divided by 20 is the y-intercept, 600 divided by 30 is the x-intercept. Great, so we can graph the line. X-axis, y-axis, there's a line, and we'll call this 20 and this 30. Note that we're dealing with a strictly less than, so I erred in drawing the line like that. I need a dotted line because it's strictly less than, and so therefore I need whichever side that I'm interested in, I need the dotted line. Which side? Well, we know one side is a greater than side, right? So one side has 30x plus 20y is greater than 600. One side has 30x plus 20y is less than 600. So all we need to really do is try one test point. And usually x equals 0, y equals 0, right? The origin. Well, that's not on the line, so it's on one side of the line or the other. If we plug that into the inequality, what do we get? 30 times 0 plus 20 times 0 equals 0, and that is less than 600. So the origin, 0, 0, is on the less than side. And that's the side we want. So we must want everything out here. Right? That would be the less than side. Okay, great. Are we done? Well, not quite. What about these suckers? X greater than or equal to 0, y greater than or equal to 0. So if we think about the plane, here's my x-axis, here's my y-axis. Positive x's are here, positive y's are here. Usually this is called quadrant 1, and in that quadrant your x coordinates are positive and your y coordinates are positive. This is quadrant 2, you go, what's that, counterclockwise? Quadrant 3, quadrant 4. In this section here, all your x's are negative because you're on this side of the y-axis, and all your y's are positive because you're on the top half of the plane. And down here your x coordinates are negative and your y coordinates are negative. And down here now your x coordinates are positive but your y coordinates are negative. Great. Oops, negative. So what does that mean if we're looking about these inequalities? Well, we're interested in only the first quadrant. So that's what those two means. So putting these together then, we want this and also those inequalities. 30x plus 20y less than 600. That gives us a whole big region of the plane, this whole half plane out here. The inequalities x greater than or equal to 0, y greater than or equal to 0 means only in quadrant 1. We're only interested in that part. So if we draw our graph again, only in the first quadrant, so I'm not going to include any of that. Our y-intercept was 30, and our x, oops, it's supposed to be a dotted line because this is strictly less than, and our x-intercept was 20. And it was this side over here that I was interested in. So let's go with red. So it's only this part. Right? The only part of the inequality that we're interested in is the part that's in the first quadrant. Like that. Great. So these are coordinates in the plane where if you pick a point in here, if you plug in its x coordinate, y coordinate, and multiply them out according to this rule, you get something less than 600, and the x coordinate and the y coordinate are both positive. The greater than or equal on the x greater than or equal to 0 and the y greater than or equal to 0 means we're including the parts of the axis there. The strictly less than there means we're not including the line itself. Great, and so that's how we can graph this set of inequalities. Okay, well, here's a counterexample, not a counterexample, but going the other way. Here's a line, a region, and we want to figure out, this is the solution, this is the graph that we got. What's the inequality that we started with? Okay, well, we can look at this and we can say, question 1, what's the line? And we know what the x-intercept is. That's 24 right there. And we know what the y-intercept is. That's minus 20. So what's the equation of the line? Well, we know 2 points on the line. And once you have 2 points, you can figure out the equation. So what's the slope? Rise over run. If we start here and go from here and then over, we go up 20 and right 24. So the slope is up 20 and right 24. And that is, if you divide out the 4s, that's going to be 5 over 6. Okay. So what's the equation of the line? Well, we're in good shape here. We know what the y-intercept is. We know what the slope is. So y equals mx plus b. Y equals 5, 6x minus 20. Usually in Chapter 5, we want to have the line in standard form. So I will multiply both sides by 6. That'll give me a 6y. Multiply 5 6 by 6. Then the 6's cancel out. And 20 by 6 gives me 120. And we'll move the 120 over to the left side and the 6y over to the right side. And generally, an equation like that, everything's an integer, no fractions, and the x and the y on the same side and a constant on the other side. Usually in Chapter 5, that's how we do that, present lines. So this is the line, 5x minus 6y equals 120. We want this side of the line, the shaded side. Is that the less than side or the greater than side? Right? One side of this line is 5x minus 6y is greater than 120. One is 5x minus 6y is less than 120. So pick a point in the region you like. Right? And suppose we pick x equals 20 and y equals 10. That's nicely safe in the region that we want. And we'll plug that into the expression on the right-hand side. 5 times 20 minus 6 times, that's not 10, that's actually minus 10 because we're below the x-axis. So this is the point 20 minus 10. So 5 times 20 is 100. Minus 6 times minus 20, that's plus 60. That's 160. And that's bigger than 120, right? That's what the line is. So we pick a point that's off the line, and we found out if we plug these numbers in here, we got a number that's bigger than 120. So this side must be the less than side. The line here is dashed, so we don't want that. So what's the inequality that gives rise to this? Well, 5x minus 6y is greater than 120. Right? This is the line. This is one side, so it's got to be greater than or less than. We don't want a less than or equal because it's dashed. We tested a point in the shaded region. We found it was greater than. And so the whole region must be 5x minus 6y is greater than 120. So how do we go from words to these kinds of problems? We have to take sentences and turn them into inequalities. So here's one sentence that we hope will be true. That is that the Twins will finish the season with at least 4 more wins than the White Sox. How do you turn that into an inequality? First thing to do, define your variables. Always the first thing to do in dealing with a word problem. So we'll let capital T equals Twins wins, capital W equal White Sox wins. These are 2 baseball teams. And the season just started. So, Twins will finish the season with at least 4 more wins than the White Sox. So what does that mean about the Twins? At least 4 more wins. That could be 4 more wins, or 5 more wins, or 6 more wins, or 7 more wins, however many more wins. So how many wins will the Twins have? They will have at least 4 more than whatever it is the White Sox win. So this is how much the White Sox will win, plus 4. The Twins' amount of wins will be greater than or equal to that. So we can turn sentences into inequalities. I think all these M's here were supposed to be commas, and I just missed the comma. So problems 15, 17, 19, 27, 29, 31, they just give you a bunch of sentences and say turn it into an inequality. Always define your variables, and then second, find the inequality. At least, right, greater than or equal. At most also would be the less than or equal, and you just sort of need to figure out what the inequalities are going to be. Okay. And here's where we actually start doing some word problems, right? A furniture manufacturer makes tables and chairs. Tables take 7 hours to assemble. Chairs take 3 hours to assemble. And every day, the manufacturer has at most 210 labor hours available for assembly, right? So maybe there's, excuse me, maybe there's 105 people, and they can each work 2 hours, and that would give you 210 labor hours. Okay, so how many types of each furniture can the manufacturer make? The question has got a lot of possible answers. The book, when dealing with these problems, says this. Express your answer as a linear inequality with appropriate non-negative restrictions and draw its graph. Okay, so what does that mean? Well, it's like a word problem. We need to figure out our variables and stuff. So we'll start by making a table. We're interested in tables, making tables and chairs, right? How many of each type? So how many tables, how many chairs? We need to give each one a variable. X and Y are traditional variables, so we'll call the number of tables X and the number of chairs Y. What do we know about assembly? It takes 7 hours to make a table, and it makes 3 hours to assemble a chair. Oh, and we'll put a little total here. How much hours are available? At most, 210. So however many hours they use for assembly, it has to be less than or equal to 210. So there, a little table. Great. So what's our inequality here? Well, each table takes 7 hours, so 7 times x is the amount of time it takes to make x tables. Each chair takes 3 hours. And if you're making y of them, 3 times y is the number of hours it takes to assemble chairs. So this is the total number of hours you have to use in order to make x number of tables and y number of chairs. And you need to that to be less than or equal to 210. Setting up a table in this way makes it really easy to see what the inequality is. 7x plus 3y has to be less than or equal to 210. So there's my linear inequality. What are the appropriate non-negative restrictions? Well, in word problems like this, you're not going to be making negative tables, and you're not going to be making negative chairs. The number of chairs tables you make has to be greater than or equal to 0. You might make 0 of them. Who knows. And the number of chairs you make has to be greater than or equal to 0. So there's my non-negative restrictions. Great. So now we need to draw its graph. And this is like the previous problem we had with non-negative restrictions. So now we're down to just drawing this graph. How do we do that? Graph the line first. We do that by finding the x-intercept, which is 210 divided by 7, which in this case is 30. And what's the y-intercept? It's 210 divided by 3, which in this case is 70. Okay, greater than, less than or equal, so that means we want a solid line. X greater than or equal to 0, y greater than or equal to 0, that means we want only the first quadrant. So x-intercept is 30, y-intercept is 70, so that'll be up here somewhere. Great. So that's what our graph looks like. Almost. We need to figure out which side that we're interested in, right? That's the graph of the line. 7x plus 3y equals 210. One side is greater than and one side is less than. Which is which? Take a test point. Right? X equals 0, y equals 0 is not on the line. Right? It's over here somewhere. Which side of the line is it? Is it on the less than side or is it on the greater than side? Well, plug it in. 7 times 0 plus 3 times 0. So we take x equals 0, y equals 0. We plug it into my inequality. Where's my inequality? It's here. And that gives me 0, which is, in fact, less than or equal to 210. So 0, 0 is on the less than side of the graph, and that's the side that we're actually looking for. But we only want the side of the graph that's in the first quadrant. So we just shade this triangular area. So there's our solution to this problem. And so in section 5.1, right, when you see word problems like this, they're not asking for numbers as a solution. They're asking for a graph, an inequality, and a graph as a solution, right? So not, 7 and 5 or something like that. Okay, a slightly more complicated version is this. Same idea, but a little more complicated. A farmer wants to use 2 brands of fertilizer for growing corn. Brand A has 20% nitrogen, 2% phosphate, and 5% potash. Brand B has 25% nitrogen, 4% phosphate, and 2% potash. So, if there's at least 100 pounds of nitrogen per acre, how much of brand A and brand B should be used? If there's most 20 pounds of potash per acre, how much of brand A and brand B should be used? And again, the answers aren't numbers in this case, the answers are graphs and inequalities. Okay, so what do? Well, we'll set up a table. Tables are always very useful things. And we have, what's the question asking? How much of brand A? How much of brand B? So, how much of brand A? How much of brand B? That goes at the top of my table. And the very next thing I need is, what are my variables? We'll call the pounds of brand A that we're going to use X, the pounds of brand B that we're going to use as Y. So these variables are pounds of X, pounds of brand A, and pounds of brand B. Okay. So, what else do we need to know? Well, nitrogen, phosphate, and potash. And we can put in, let's see, a little line here. And of course, we need a totals column. If I could type as fast as I write, I would just use the table tool in Excel for this. But anyway, so nitrogen. If we're using X pounds of brand A, how many pounds of nitrogen are there? Well, 20% of brand A is nitrogen. So if we have X pounds, how much pounds of nitrogen we have? Well, 0.2 times X. Right? So if there's 100 pounds of brand A, 20% nitrogen, that means 20 pounds, right? 0.2 times 100 of nitrogen. Brand B is 25% nitrogen. If you have Y pounds of brand B, then you have 0.25 Y times Y pounds of nitrogen, right? So if you had 1,000 pounds of brand B, how many pounds of nitrogen would you have? Well, 25% of 1,000, which is 0.25 times 1,000. So likewise, phosphate, 2% of phosphate in X pounds, so 0.02 X. For brand B, it's 4% phosphate, so that would be 0.04 times Y. And then 5% potash, I think is how it's pronounced, so 0.05 X. And 2% potash, well, if something is 2% potash and you have Y pounds of it, then you have 0.02 Y pounds of that. And then we have 2 problems. Part A says at least 100 pounds of nitrogen. So at least means you need more than that, greater than. So you need greater than, for nitrogen, you need greater than or equals to 100. At most 20 pounds means you can't have more than that. You have to have no more than 20 pounds. So however many pounds of potash you have, the pounds of potash you have to be less than or equal to 20. And this is for part A, this is for part B. Great, so what's the equation for part A? 0.2x, that's the pounds of nitrogen in brand A, plus 0.25y, the pounds of nitrogen in brand B. This is how many pounds of nitrogen you're going to be dumping on your field. And you want that to be greater than or equal to 100. You want to have at least 100 pounds of that. And of course, the non-negative restrictions, x greater than or equal to 0, y greater than or equal to 0. To graph this, we start with taking the line here. Your x-intercept is 100 divided by 0.2, which is 500. Your y-intercept is 100 divided by 0.25, and that is, what was my totals? 400. Great. So we only want the first quadrant because x is greater than or equal to 0 and y greater than or equal to 0, so only in this area. X-intercept, y-intercept. This is 400 is my y-intercept. 500 is my x-intercept. Greater than or equal, that means a solid line. Which side do we want? Well, what's our test point? I usually take, if the origin is not on the line, 0, 0 is my test point. Take that, plug it into here. 0.2 times 0 plus 0.25 times 0. Well, that equals 0. And that's actually less than 100. So 0, 0, the origin is on the less than side of the line. Well, we don't want the less than side. We want the greater than or equal side. So which side do we want? We want this side. And what area do we want? Well, we want only the area that's in the first quadrant. So just this area. And remember that the non-negative restrictions mean that this is the boundary that we're dealing with. Right? So everything up in here. Great. So any combination of brand A, that's your X, and brand B, that's your Y, that comes from in this region, that will get you enough nitrogen for your plants. And then, oops, seem to have run out of paper here. We should be able to, let's see if we can get an extra page. Well, we'll just do it in a very small space. For part B, what's our inequality? 0.05x plus 0.02y is less than or equal to 20. If you graph that, you get an x-intercept of 400 and a y-intercept of 1,000. Well, we'll move our x-intercept over there. I don't know if I can erase that. And then this is 1,000. Okay, so there's our x-intercept and a y-intercept. What's our test point? 0.05 times 0 plus 0.02 times 0 equals 0. That is, in fact, less than or equal to 20. So 0, 0 is on the less than side. That's the side that we want. But because we have x greater than or equal to y, x greater than or equal to 0 and y greater than or equal to 0, that means that we only want the part that's in the first quadrant. And so our solution is this triangle, the interior over it, and the boundaries. And so any combination of potash and brand A and brand B that's in this area, so if you had 100 pounds of one and 100 pounds of the other, that will make sure that you have less than 20 pounds of potash there. And of course, what we'll see in 5.2 is we can combine these two and say, okay, well, can we get a region where we get enough nitrogen but not too much potash? How much should we have of each to get